Have you ever looked at a farm field and wondered why some are small and meticulously managed, while others stretch for miles with seemingly less intervention? The way we use land for agriculture varies immensely across the globe, directly impacting ecosystems, economies, and food production. Understanding these fundamental differences is key to appreciating global food systems. Intensive and extensive land use patterns representing two contrasting approaches to agriculture, primarily distinguished by the amount of capital, labor, and technology applied per unit of land. Intensive agriculture seeks to maximize output from a smaller area, while extensive agriculture aims to produce a moderate yield over a very large land base. The core mechanism driving these distinctions lies in resource allocation and desired productivity goals. Intensive farming invests heavily in inputs like fertilizers, pesticides, irrigation, and specialized machinery, alongside significant labor, to achieve high yields per acre or hectare. This approach is common in regions with high population density or limited arable land. Conversely, extensive farming relies more on natural conditions and requires less capital or labor per unit area, often characterized by lower yields per unit of land but higher overall production due to vast scale. This is typical in areas with abundant land and lower population densities. Recognizing these patterns helps us analyze global food security and environmental impacts. When you see dense crop fields, often with multiple harvests per year, or concentrated livestock operations, you are observing intensive practices. These systems aim for maximum output to feed large populations. In contrast, vast grazing lands for cattle or large-scale grain production using minimal artificial inputs over thousands of acres exemplify extensive land use, often found from urban centers. One insightful concept is the idea of agricultural intensification, which refers to the process of increasing agricultural production from a given land area. This often involves adopting advanced techniques, better seed varieties, or improved animal husbandry. Extensive systems, while having a lower carbon footprint per unit area, can also lead to habitat loss if natural lands are converted for their expansion, whereas intensive systems often face challenges related to nutrient runoff and soil degradation. Both types of agriculture are essential, but each carries a unique set of trade-offs that influence food supply and ecological balance. Ultimately, understanding the comparison between intensive and extensive land use illuminates how human societies adapt food production to their available resources and environmental contexts. It highlights the complex interplay between land availability, economic pressures, technological advancements, and ecological considerations, shaping the future of our global food supply.